In our 10th problem, we need to find the locus of the point, the chord of contact of the tangents from this point to the circle, to the hyperbola x square by a square minus y square by b square is equal to 1 touches the circle which is made having diametrically extreme points as the two focus of the hyperbola. Now let the point be h comma k from which two tangents are being drawn to the hyperbola. The equation of chord of contact can be directly written in the similar fashion by replacing one of the x by the point h by a square and replacing one of the y by the point k by b square is equal to 1. This is an important trick which you should always remember, that if there is a curve, let us take the example of a circle x square plus y square is equal to r square, and there is an external point h comma k and two tangents are being drawn to the circle, then the equation of chord of contact can be directly found out by replacing one of the x by the x coordinate of the point and replacing one of the y by the y coordinate k of the point to get the equation of chord of contact to be equal to xh plus yk is equal to r square. This method or this trick is applicable to any curve, be it ellipse, circle or hyperbola. Hence in this case the equation of chord of contact comes out to be equal to xh by a square minus yk by b square is equal to 1. Now it is given that this chord of contact is tangent to a circle and the circle is made in such a way that the diametrically opposite points are the two focus of the hyperbola, and we know that the two focus of the hyperbola are AE, 0 and minus AE, 0, where E is the eccentricity of the hyperbola. So using the formula x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0, which is the equation of the diameter having diametrically opposite points x1, y1 and x2, y2, we get x minus AE into x plus AE plus y minus 0 into y minus 0, that is y square, is equal to 0. This gives us x square minus a square e square plus y square is equal to 0, or x square plus y square is equal to a square e square. This can be further simplified as e square we know that is equal to, or rather we know that b square is equal to a square times e square minus 1. This is equal to a square e square minus a square. Hence we can write this a square e square as a square plus b square. Hence the equation of circle becomes x square plus y square is equal to a square plus b square. Now it is given that this chord of contact xh by a square minus yk by b square is equal to 1 touches this circle. Hence if we drop a perpendicular from the center on this chord of contact, it will be equal to radius of the circle. Hence on dropping perpendicular from the center, that is 0, 0, we get 1 upon under root of h square upon a power 4 plus k square upon b power 4 is equal to the radius, which is equal to under root of a square plus b square. On squaring both the sides, we get x square upon a power 4 plus y square upon b power 4 is equal to 1 upon a square plus b square. We have replaced h by x and k by y to get the locus of the point from which the chord of contact of the tangents made is touching the circle, which is made having diametrically opposite points at the two focus of the hyperbola, and the locus is x square by a power 4 plus y square upon b power 4 is equal to a square plus b square, and this is our final answer.